Hi everyone, this is Naim Khan here as a working internship candidate in Spark Foundation as a data science and business analytics. And so this is second project as a internship candidate. So I want to prediction using unsupervised machine learning. So in this task it is required to predict the optimum number of cluster for the iris datasets. So that consists three type of features. One is the Setosa, versicolor, and its virginica. So if you have not knowledge about iris data, you can go to Google. Iris data, this one. You can learn from here more about this. Is very good clusterization by using k-means clustering. So today we are going to perform some function on this. I have already coded in Python. This is a Jupyter notebook. If you have a Jupyter notebook installed inside it, you can just search from here, or you can use cmd command. So I am just going to run the following process. So friends, the main goal is what? Our goal is to find the optimum number of clusters by using iris dataset. So iris dataset is concerned about the flower. It contains different type of features. So here we can conclude three type of features that is also mentioned here. So this project is completed under 5 steps. First one is importing the data set and importing the different type of libraries which is used to visualize, plot, and numerical calculation and other. So the next step is visualize the data sets and define the optimal number of clusters, applying the k-means cluster in the data set and visualizing finding optimum. This is the algorithm. That is the k-means clustering algorithm. So come to the first step here. I want to import some libraries here: numpy, pandas, matplot, sklar, and that is used in sklar k-means clustering algorithm. So just run this one. It is good. I read this one. I want to read or load the data from the local machine. I read it here. This is our dataset iris.csv file. If you not know about how can import data from local machine, just control plus B, such type of interface you got, and you can import from this side. So here is dataset and you can import. I already import, so no need to here. So again, just control B and such type of good interface. I read and load data from local machine to Jupyter notebook. It is loaded. Just I want to check what type of labels mentioned inside the CSV file. So just check head of the file. The head contains different type of attributes. Here sepal length, width, and petal length, petal width, spaces. So I just want to check shape. How many rows and column here? Here 150 and 6. So just data frame columns. This shows here such type of inside the data frame. So I want to also check the information, either it contain null values or not. So here all values, ID, sepal width, average length, width, petal length, width, and all these have no null values. So it is good because of the good visualization. So we read here in number 3 step. So just we want to plot the all figures. I want to run this code. It shows a very good looking here. You can see this one, a very here 4 red color and blue, and here once again a sky color. These colors are mentioned here in this code. Scattering: when iris data ID given simple length, such type of car. So all these are mentioned above here. So when they execute this one, there's such type of output. So now we want to find k means. What is k? K is the number of clusters. So here we will understood the meaning of k by classification of simple length and its width. So 2 and 5 clusters, we will measure the centroid of each cluster and plot them onto the graph. So first we want to find the number of cluster because it is unsupervised. In supervised, what is unsupervised? What is unsupervised? Unsupervised, the number of clusters or the number of parameters as given. That is supervision. If we have no information about the data, then it is unsupervised learning. So here we work on the unsupervised learning. So here this k-means and cluster. I want to find k-mean center. K-means center. I just run. This is the k-mean center. I want to check the labels. How many type of data. So just execute this one. It is goes to good plot here. These are the optimum clusters. So more about checking, just execute this one. Here also we use k-means clustering algorithm. It shows here all processes mentioned. You can read from here. I have to say for the sake of time, I just execute this one. All steps already mentioned upper side. This is our code, and when we run, it shows such type of output. Here is very good correlation between the number of clusters and with the sum of the k-means cluster. So we just this is markdown and this is observation. We can clearly see why it's called the elbow method. Here one thing this is elbow method because it shows its graph just like a elbow. Sorry friend, it shows just like a elbow. That's why it's called elbow method. So the observation here, the optimum cluster is where elbow occurs. This is when the within cluster sum of square. It is also double CSS doesn't decrease significantly with every iteration. For this we choose the number of cluster as 3. So when the number of cluster is 3, what will be happen the next? So we just create classifier, that's k-means classifier. So we create classifier and want to print the labels. It shows such type of, and we just check the simple length. Let's figure this code is, you can understand if you have knowledge about Python. This is a clusterization from the raw output for the simple length. Here we try to classify the simple length at simple width. The classification is also shows here. These are the length of the simple width. So I just try to plot this one under the given code. Classifying for 6 combinations. We have 6 combinations between the simple length and width, petal length, petal width, simple length versus petal width, so on. You can learn from here. I just the code here from, you can understand from here and other platform. So I want to get good classification output. Just wait one moment. Good. Here all the combinations which is mentioned inside here. So its output is here. It is very good output, good clusterization. This is pattern data types. You can save your information such type. So our goal is good. So just here once again we check the accuracy or prediction, either our clusters are good or not. We just check. So once again read the and labeling the data for accuracy purpose or prediction. Just read the head. Here I want to pair plot. Pair plot, you can also learn more about pair plot. Pair plot. Pair plot is just like a tool, two-dimensional tool. You can also study from the browser. This is our task. So all other link is data and Kaggle link. My account is also mentioned here inside the description. You can follow from that side. So when I run this one, we got such type of output for petal width and sepal width. So we just try the dimension. This is the group of cluster 1 type, 0 type and 2 type. So we just define three number of clusters, and the K means clustering. So just we check the accuracy. Here 66 accuracy we got from that one. So this is our second project in Spark Foundation. I'm very thankful Spark Foundation. I got good learning from Spark Foundation. It is very good platform. You can learn from Spark Foundation. Thank you so much.